Hello friends, welcome to all. Myself Vishal Sugidas. Today we will discuss about crawling and cogging of induction motor. And this topic is covered in the subject of electrical machines too. First we will see crawling of induction motor. Sometimes squirrel cage induction motor exhibits a tendency to run at very slow speeds, as low as 1/7 of their synchronous speed. And this phenomena is called as crawling of an induction motor. See, this is the phenomena. In this case, the induction motor will run at almost 1/7 of their synchronous speed steadily. It means there is no other problems are there. Only the motor will run at 1/7 of their synchronous speed. Now question is how it is possible and what are the cases of this. So let us see. This action is due to that fact that flux wave produced by a rotor winding is not purely sine wave. We know that whenever we are giving a three-phase supply to the stator, due to this the flux is generated in the rotor, and this flux will not only purely sine wave. Okay, so what is the impurity is present in the sine wave? Because it is not pure sine wave, then some impurities may be there. Instead, it is a complex wave consisting of fundamental wave and odd harmonics like third, fifth, and seventh, etc. See, the stator flux produced in the stator winding will not be purely sinusoidal, but it will be complex wave. And in a complex wave, there are fundamental wave, then odd multiple of harmonics like third harmonics, fifth harmonics, and seventh harmonics are there. Now, if we have to define harmonics, what is harmonics? See, harmonics is a, if we have to define third harmonics, then we can say that the frequency of third harmonics will be 3 times the fundamental frequency. It means, for example, there are 50 Hz frequency, then frequency of third harmonics will be 150 Hz, and amplitude of third harmonics will be 1/3 of the fundamental wave. This is the definition. This is true for nth harmonic. It means if we have to define nth harmonic, then its frequency will be multiplied by n. It means n into its fundamental frequency, and its amplitude will be fundamental amplitude divided by n. It means it was in division. So this way we can define the harmonics. The fundamental wave resolves synchronously at synchronous speed. Fundamental wave speed of fundamental wave is always synchronous speed ns, whereas third, fifth, and seventh harmonics may rotate forward or backward direction at ns by 3, ns by 5, or ns by 7 speeds respectively. It means for third harmonic its speed will be ns by 3. It means synchronous speed divided by 3. For fifth harmonic its speed will be ns by 5, and for seventh harmonic it will be ns by 7. So this is the harmonics presence. Hence harmonic torques are also developed in addition with fundamental torque. See, in addition to fundamental torque, there are some torques also, and this torque known as harmonic torques. Because due to third harmonic there is some torque, due to fifth harmonic there is some torque, due to seventh harmonic there is some torque. So This is the torque produced due to harmonic is known as harmonic torques, and these torques are present in the motor. Third harmonics are absent in a balanced three-phase system. See, this is important thing regarding harmonics. Okay, if our system is a balanced three-phase type system, then there is no third harmonics. It means third harmonic will be eliminated from the system. So this is the major advantage of balanced three-phase system. Hence, third harmonics do not produce rotating field and torque, because it is not present, then its effects will also not present. We have already seen that due to third harmonics there is some harmonic torque, but if the third harmonic is not present, then harmonic torque also not present, and rotating field will also not present. The total motor torque now consists of three components. First one is fundamental torque, and its speed will be synchronous speed ns. Second component will be fifth harmonic torque with synchronous speed ns by 5, and fourth component is seventh harmonic torque with synchronous speed ns by 7. Okay, that we have seen in a previous slide, provided that higher harmonics are neglected. Now question is why the higher harmonics are neglected. See, up to 7th harmonics it is okay, but if we are going to the higher order harmonics, the frequency will be increases. That we have seen that if we are talking about 11th harmonic, then in 11th harmonic the frequency will be 11 into fundamental, so it is very high, and amplitude of that harmonic will be 1 upon 11th times the fundamental amplitude. So its effect is less because the amplitude is very small and frequency is very high. So we can neglect the effect of higher order harmonics. Major effect will be from 5th and 7th harmonic, and this crowding phenomena is also comes into picture due to this 5th and 7th harmonics. So for our understanding purpose and for analysis purpose, we can say that we can neglect the higher order harmonics from the system. Now, fifth harmonic currents will have phase difference of 5 into 120. See, we know that in a balanced three-phase system, there is a phase difference of 120 degree between any two phase. Okay, but in a fifth harmonic it will be 5 into 120, so it is 600 degree centigrade, 600 degree, and we can divide or part this 600 degree into 360 degree. It means 2 into 360 minus 120 degree. See, we know that 360 is a complete one cycle. It means if there is a 360 degree, then we can consider it as a same as 0 degree. So for 600 degree we can write this 2 into 360 minus 120 degree. So 360 degree means 0 degree, so we can consider it as a minus 120 degree. Hence, the revolving speed setup will be in reverse direction with speed ns by 5. Okay. The small amount of fifth harmonic torque produces braking action and can be neglected. See, if there is a phase difference is 120 degree positive, then it will be the balanced three-phase system. But if the phase difference is minus 120 degree, it means the direction of the speed will be in reverse case. It means actual direction is in clockwise direction. Then due to this fifth harmonic, the speed ns by 5 speed will be in a negative direction. It means counterclockwise or anti-clockwise direction. The small amount of fifth harmonic torque produces braking action and can be neglected. See, due to this reverse direction, obviously there is a braking action because actual speed is in the clockwise direction, and this due to this fifth harmonic, the speed will be ns by 5 speed will be in the reverse direction. So some amount of speed will be decreases due to this, and this can be considered as a braking action. And because of this small amount, we can neglect this. The seventh harmonic current will have phase difference of 7 into 120. It means it is 840 degree. Okay, so if we rearrange this, we can say that it is 2 into 360 plus 120 degree. See, in this case we have to give plus 120 degree. So it is 2 into 360 plus 120, but we know that 360 and z is equal to 0 degree. So answer will be plus 120 degree. Okay. Now, hence, they will set up rotating field in forward direction with synchronous speed equal to ns by 7. See, in this case, there is a phase difference of plus 120 degree. So due to this, the synchronous speed ns by 7 will be in the forward direction or positive direction. If we neglect all the higher harmonics, the resultant torque will be equal to sum of fundamental torque and seventh harmonic torque. See, there are number of harmonics are there in the system, but if we have already seen that higher order harmonics effects are very less, so we can neglect. So if we neglect higher order harmonics, then resultant torque will be only fundamental and seventh harmonic torque. Seventh harmonic torque reaches its maximum positive value just before 1 upon 7th of ns. Okay, seventh harmonic torque reaches its maximum positive value before 1 upon 7th of synchronous speed. If the mechanical load on the shaft involves constant load torque, then the torque developed by the motor may fall due to load torque. In this case, motor will not accelerate up to its normal speed, but it will run at a speed which is nearly 1 upon 7th of its normal speed, as shown in figure. And this phenomena is called as crawling of an induction motor. Okay, so what will happen in this case? We have already seen that there is a maximum positive value will be just before the 1 upon 7th of the synchronous speed, and if the load torque is a constant load torque, so at that time what will happen, torque developed by the motor fall due to this load torque. Okay, and motor will accelerate up to its motor will not accelerate up to its normal speed, but it will run at reduced speed, and this reduced speed will be 1 upon 7th of the synchronous speed. So this is the criteria, and this phenomena is known as crawling of an induction motor. Now this is the graph of torque versus slip torque slip characteristics and torque speed characteristics. Here we can say that in this region there is a stable region. Okay, it means in a stable region there is a slip is near to 0. Okay, and speed is near to synchronous speed. And this region is known as unstable region. It means motor will not work in this region. Here is we can see this dotted line is a constant torque line. Okay. Now here we can see the crawling speed. This is the crawling speed. It is we can say that it is almost 1/7 of the synchronous speed. So in this case also there is a stable region in this case. Okay, this one is the stable region. So we can observe here that the amplitude is this, maximum speed is here, but due to crawling there is a reduced torque will be also there. So frequency is also reduces, because here we can see this is only half cycle, same type of half cycle will be here. So we can say that it is a due to the seventh harmonic component, the crawling speed will be there, and it will be the nearly 1/7 of the synchronous speed. So this is the case with the crawling in induction motor. Now we will talking about magnetic locking or teeth locking of induction motor. This is the second phenomena we are going to discuss for induction motor. Sometimes the rotor of a squirrel cage induction motor refuses to start at all, practically if the supply voltage is low. It means sometimes what will happen, induction motor will not be able to start, particularly when the reduced supply voltage is there. So what is the reason for this, and how it is possible? This happens especially when number of rotor teeth is equal to the number of stator teeth. Okay, the reason behind this is here, if the number of rotor teeth is equal to number of stator teeth, then there is a magnetic locking or teeth locking will be there. And because of magnetic locking between the stator teeth and rotor teeth, okay, when the rotor teeth and stator teeth face each other, the reluctance of the magnetic path is minimum. That is why the rotor tends to remain fixed. This phenomena is called Cogging or magnetic locking of induction motor. Okay, so this phenomena is called as Cogging, or sometimes it is known as magnetic locking of induction motors. So this is the phenomena can be observed in induction motor. So induction motors have a series of slots in the stator and in the rotor. Okay, these slots should not be equal in number, because if they are, there is a good chance that the motor will not start at all due to the characteristics known as cogging. Okay, so cogging is nothing but the motor will not start, and particularly at some reduced voltage. Okay, so the slots will align like a stepper motor. Now for this reason, there are an unequal number of slots in the rotor and in the stator. So this is the remedy actually. How can we stop this cogging? So there are an unequal number of slots in the rotor and in the stator. But there can still be situations where the slot frequencies coincide with harmonic frequencies, and this can cause torque modulations. Okay, so if the stator and rotor number of slots are not equal, then also there is a tendency for this cogging. So what is the remedy for this? The slots are skewed to keep an overlap on all slots to reduce this problem. Okay, so the slots are skewed. It means it is not in a straight line, but it is skewed to keep the overlap of all slots to reduce this problem. So these two are the remedies for cogging. Thank you.